Rod said that I'm hard to get a hold of for doing it, so I'm finally fulfilling my obligations. So I'm very happy today to talk about orchids. Rod suggested this topic, and it's one of my absolute favorites. If you ever have anyone in your life that thinks botany is boring, you can win them with either orchids or carnivorous plants, which we have both of on the peninsula. So today I'm going to do a deep dive, kind of more into orchid-like lifeways and biology of more than going through every species. But we'll see a lot of our local species today. And all of the illustrations and photographs in here are mine, unless they have got a little website beside them, then they're someone else's, or a little label. So I wanted to start with, I'm sure some of you have heard this quote before, and I'm going to actually read it out to you. John Muir was a very famous conservationist, and he did all kinds of other things too, but for a very short time, he actually lived in Meaford, Ontario, and he worked at a lumber mill there, and he would kind of walk around parts of Ontario. He went on later to become very, very famous for protecting like all kinds of lands, including being kind of one of the core reasons the National Park Service in the States was set up. He was very good friends with Roosevelt, and Yosemite and Redwoods and all those kinds of parks were kind of set up thanks to his good work, and he was kind of ahead of his time when it comes to conservation thinking. But he has this really great quote about a time when he was living in Meaford, and then he kind of went traipsing around through the bush seeking to look at a certain orchid. And I might cry a little bit when I read this, just to warn you. It's an emotional experience. Okay. The rarest and most beautiful of all the flowering plants I discovered on this first grand excursion was Calypso borealis, which is the orchid picture. The hider of the north. I had been fording streams more and more difficult to cross, and wading bogs and swamps that seemed more and more extensive and more difficult to force one's way through. Entering one of these great tamarack and arbor vitae swamps, arbor vitae being cedar, one morning, holding a general, though very crooked course by compass, struggling through tangled drooping branches and over and under broad heaps of falling trees, I began to fear I would not be able to reach dry ground before dark. But when the sun was getting low and everything seemed most bewildering and discouraging, I found a beautiful calypso on the mossy bank of a stream, growing not on the ground but on a bed of yellow mosses, in which its small white bulb had found a soft nest, and from one of its leaf and flower sprung. No other bloom was near it, for the bog was a short distance below the surface, was still frozen, and the water was ice cold. It seemed to me the most spiritual of all the flower people I had ever met. I sat down, see, here I go. I sat down beside it and fairly cried for joy. And so then later in his career, he was writing about the calypso, and he said, "It seems wonderful that so frail and lovely a plant has such power over human hearts. This calypso meeting happened some 45 years ago, and it was one of my more memorable and impressive than any meetings with human beings, excepting perhaps Emerson and one or two others," which I think is so funny. So that's the how impactful some of these little plants can be. And indeed, if anyone's ever seen a calypso, they grow here locally, particularly on Flower Pot Island. They are a remarkable little orchid, and they're only about that tall. This is another quote I really love. So there's a book, there was a naturalist by the name of William Hamilton Gibson, who was kind of an interesting character. He wrote a ton of natural history books, he illustrated them, and then he kind of died before he ever became famous, and his family won't let people publish things, and there's all kinds of weird stuff, so you have to find some of his old books or find them online. But his book on orchids is probably the best one I know of. So this really old book is probably my favorite book on orchids for local orchids, even though there's all kinds of new ones. And he has this great quote where he talks about the orchids are the nobility of the flower world. They are a race set apart, no common garb is theirs. I just love this quote. So orchids have had this kind of captivating role in our world for a long, long time. We'll talk about some orchid delirium and other things later. But I do want to say, I started off my presentation with this kind of nice, beautiful, our native orchids, aren't they wonderful? But truthfully, I could call this presentation Thieves, Liars, Mooches, Drug Hooks, and Sexual Deviance, because that is pretty much orchids and summed up in a nutshell. Now we get into the cool button. So the Orchidaceae family is one of the largest, if not the largest, plant family in the world. It's really kind of interesting how successful they are as a plant family. The only other one that rivals them would be the aster family. So that's things like, your sunflowers and dandelions and that kind of thing. The flowers are what botanists call zygomorphic, meaning they're kind of bilaterally symmetrical instead of being radially symmetrical. They have kind of interesting floral structures. What we would traditionally call male and female parts of the flower are kind of fused into one structure called the column. Usually there's a singular petal on the orchid, which we'll talk about in a bit, that's kind of heavily modified to make it look like, kind of have this fancy part to it. They have remarkably tiny seeds for the most part. In fact, their seeds are like basically dust, so we're going to talk about that. And they often have this feature called resupination, where they actually twist as they bloom, so we'll talk about that. So there's orchids throughout the world that do have medicinal value, including some of our local ones for Anishinaabe people. But the biggest thing we know about orchids, that for any of us, is that vanilla is actually an orchid. So if you think about when you break open a vanilla pod and there's all those little flecks, those are those tiny seeds. So that's where the flavor of vanilla comes from, and that's an orchid plant, or an orchid product. Of course, there's their commercial value as ornamentals. That's a big industry. And in fact, in the Victorian area, this industry was very, very big, which we'll talk a little bit about. There's ecotourism. So here we actually have a lot of people come to the peninsula from a tourism perspective just to see some of our orchids. I've seen people come from like Norway to come see a calypso, or come from like Germany to come see some of our plants. So it does have a potential for sustainable tourism and ecotourism. And then there's the orchid delirium phase of the Victorian period. So orchids in earnest, as we know them now, is these kind of ones you can buy at Walmart and that kind of thing. Back in the day when the English were kind of traveling around the world, traipsing and pillaging, they started seeing these amazing orchids in other parts of the world and bringing them back to England. And it caused this craze. People just fell in love with these incredible plants. And so they would pay orchid hunters to go into these various countries and take orchids and bring them back. And if they could, they would take every orchid there was so that they could be the only one that has that species. And these would sell for like $10,000 even then, and that kind of money. So we're talking big bucks. And actually today, orchid poaching is still an issue, and there's been at least 2 orchids poached in my lifetime that I was familiar with in this area. So it's still there's still a delirium, even though the Victorian period ended and you can get Phalaenopsis at Walmart. So there you go. So orchids are kind of neat from an evolutionary perspective. It's suspected they're around 80 million years old. The oldest current fossil record, I think, is 55 million years. And they find that by looking at little gnats and stuff that are in amber and get pollen stuck to them. So it's kind of neat that the dinosaurs didn't survive the great extinction, but the orchids did. And actually, they look at orchid radiation and evolution, and before the continents had kind of separated out, that's probably when orchids started to evolve. So they were probably kind of all over that big main continent, and then it separated out. So the only continent you wouldn't find an orchid on today is really Antarctica. Apart from Antarctica, desert environments, there's very few places orchids can't grow. And orchids have a really interesting plasticity in them. So they have a few different qualities. Because of their seeds being very, very tiny, they can fly up into the atmosphere and land in all these places, which means they're very good at evolving in like little islands and little places other things can't get. Because they have kind of interesting structure in their flower, it means they get kind of more diverse seed set, because they often live in places other plants can't. So about 80% of that huge population of orchids that we have in the world actually are epiphytes. So they're like this kind of orchid that would grow on trees or on rocks, whereas the rest are terrestrial. So if you can imagine, and not a lot of plants have adapted to live on trees or rocks, so that's a whole space they can take up. And then we'll talk about how our orchids have evolved to live in kind of fens in areas that other plants aren't as good at. So because of their really good adaptations at evolving and kind of their plasticity, they have been all kinds of forms of orchids throughout time.
Did you say that was a fossilized orchid?
So that's a gnat, like a little bee or a little fly, that has pollen, all those little templates or pollen stuck to it. So orchid pollen comes in a mass. We'll talk about that in a sec. I'm going to talk about it now. So one of the cool features of orchids as a family is their pollen is kind of agglutinated together in a mass. Sometimes it comes off as a little ball, and sometimes in the case of our slipper orchids, it's more like kind of a greasy smear of pollen rather than being loose and powdery. So that's a bit of that pollinia, that mass of pollen stuck to the mat. So there's around 25,000 to 30,000 species worldwide. If you combine there's probably about 140 or 200 in the United States, 75 in Canada. Those 75 would also occur in the States, so there's technically kind of, a bit of overlap there. We have about 61 in Ontario, but we have 50 species in Grey and Bruce counties alone. So, like literally a quarter of all the orchids in the entirety of North America, Canada and US, we have them here. So that's a pretty remarkable number in terms of diversity. So why do we have so many orchids on the peninsula? The first big thing is the Great Lakes. So the Great Lakes are always going to create unique ecosystems. They're the largest freshwater ecosystem in the world. They're going to produce a lot of cool, moist, humid offshore air that's going to be kind of consistent. So they're going to moderate weather, especially on a peninsula. Water takes a long time to heat up and cool down compared to the land, and so you're going to have kind of cooler, longer springs and kind of more milder falls because the peninsula is being buffered by the lake. You also get the fact that we're exactly temperate, so basically we're just a few steps away from being exactly 45th degree parallel. We get kind of post-glacial features, so as the glacier receded, these different kind of environments happened. So there was a kind of a tundra-like environment, and then it became kind of dry and prairie-like, and it has kind of maritime aspects to it, and there's all these other kind of periods of history since the glaciers receded that produce other environments. So we have an orchid, for example, called the Alaska rain orchid, which you typically see kind of more like Alaska in that kind of mountainous habitat, but because that post-glacial kind of climate mimicked that sort of boreal forest, they're still here, and because it still mimics it to this day. The other thing is the peninsula is largely intact for southern Ontario. So this is an image of basically forest cover in southwestern Ontario. Everywhere that's green is trees. And you can see the peninsula is the most intact piece of southwestern Ontario. In fact, Rocky Bay, or kind of up by Cabot Head on our corner, I think is the furthest you can get from a road in all of southwestern Ontario. And it's still pretty close to Cabot Head Road, so that's remarkable. And that's another big thing is we've actually had a lot of our habitats stay intact for longer than other parts of Ontario. So like, for example, when Muir was seeing that calypso, it's suspected he was seeing that in the Holland Marsh. And if you go to Holland Marsh today, you couldn't even imagine an orchid being there, totally different environment. But the really cool thing about the peninsula is some of the stuff we get on the western shore. So the peninsula, because it is a kind of edge of the Silurian, if you imagine the Michigan Basin, so if you imagine the Great Lakes, there's kind of a bowl in the Precambrian rock, the really old rock, and then there's these layers of sedimentary rock in the Great Lakes, and the edge of one of those layers sticks out as the peninsula, as the escarpment. So it slopes down into Lake Huron, and it's sharp on Georgian Bay. It's kind of like the edge of a big cereal bowl. And so our water will either flow through the rock out to Georgian Bay, like if you've seen little waterfalls and that kind of thing, or it'll flow over the surface of the rock to the west. And that means any low areas in the west will kind of collect that water. There's always flow, so that water's never really, you're never going to see sediment like compacting because there's always going to be water flowing through it. It's going to have a lot of like marl and dissolved calcium in it. And so it creates these fen or coastal meadow marsh environments that not a lot of other plants particularly love because it's always got water flowing through it. The soil's kind of mucky and non-compacted. So there's a few trees like your cedar and your black spruce that will live in it, tamarack, a few shrubs. Carnivorous plants don't mind it, but orchids love it because they don't have to compete with anyone else for light. All they have to do is grow in this space that nobody else wants to really grow in. So it's a great spot for orchids to be in. You'll also see like in our like calypsos and moccasin flowers, they'll grow in places like really shaded conifer forests that nothing else can really grow in. So they're kind of finding these places nobody else is that they don't have to compete with, and they're living there. So now we'll get into some orchid biology. So orchids come from a group of flowers that historically, in evolutionary terms, probably would have looked a lot like a trillium. So I'm going to use that trillium up in the upper left as my example. So you can see with the basic setup, we've got 3 petals, which are the colored part. We've got 3 sepals, which are the part that kind of enclose the petals when it's a bud. And then you've got some anthers, and then you've got the stigmatic surface where the pollen would stick to, and then it would travel down a tube, and the sperm would travel down a tube and pollinate an egg, or an ovule at the bottom. So what orchids have done is taken that top petal and made it very, very fancy. They've made the other 2 petals pretty fancy, And in some cases, they turn the sepals into kind of petals and things on display. And so when an orchid blooms, it actually sort of has to twist as it blooms, and that's because that top petal is the top one, so they need to kind of, otherwise they'd be asymmetrical. So that's called resupination when they do that twist as they bloom. And actually this is kind of hard to see, but this is one of our local orchids, and this is its nectar spur here, this big long thing. But you see how this is the ovary of the orchid, the ovaries below the flower parts. See how it's twisted? Because that orchid had to go like that when it bloomed, so you can still see it in them when they bloom today. Actually, if you look at a lady slipper, you'll see a bit of a torsion in it. Orchids are also really reliant on fungi, in a particular way compared to other plants. So they're kind of obligate mycorrhizal plants. So mycorrhizae are the tiny little kind of, if you were to call them roots of fungi, that's what they're called, is mycorrhizae, but they're not true roots. And so orchids need to kind of tap into those roots for various parts of their life cycle. You remember how I talked about the orchid seeds being like dust, like so tiny? They're so tiny, they actually have no energy or starch in them to even open up. So if you think of like an avocado seed is really, really big. If an avocado seed was planted, that little embryo's got lots of starch and fat in there that it can use to like start its life and get going and start photosynthesizing. Orchid seeds produce a lot of seeds, but none of them have any energy in them. So they're just like little, basically packets of DNA with a hard little shell. And so the orchid seed needs a fungus to start to decompose and crack open that seed coat in order to germinate. So they won't even germinate if the fungus aren't present. And then for much of their life, they'll form this little thing called a protocorm, and they'll live like that for a really long time, still might not even be photosynthesizing and depending on the fungus for bringing them food, and then they kind of finally take off and bloom. But even throughout their adult life, a lot of orchids rely on fungi to bring them nutrients. And what actually happens is the fungi will kind of go into the plant root itself, and they'll convey nutrients and steal nutrients. In some cases, some orchids will even cut that little bit of rooting fungi off and eat it. So they're almost predatory in some cases as well. And if you look at the kind of common Phalaenopsis orchid, you know this like whitish kind of bloom they have on their roots? That's a special kind of tissue on the outside of the roots that kind of becomes woody and dead, and it actually allows, it's both Velcro-y, but it also allows for fungi to get in that little dead space and live in there. So that's kind of how orchids have evolved this really intimate relationship with fungi, where they're essentially either stealing or even predating fungi. It's also interesting to think how lots of orchids are very specific to certain species of fungi. Some of them, like, it'll be just one species they need or depend on, and some of them have kind of a few species that they depend on. The moccasin flower sometimes depends on the Russula genus, which is often found kind of in these pine-type plantations. But it's really neat to think about how if you were a zinc molecule and an orchid needed, it had completely depleted all of the zinc or all of the magnesium that's in this section where its roots are. But the fungus has found a little zinc molecule over here, and it's kind of transferring through its root system. Now the orchid can access molecules and nutrients from this big wider network. So even if it doesn't have a robust root system, the fungi can bring it to it. So now we're getting into the liars and sexual deviance part of the talk. So this is one of the coolest pollination stories I think we have on the peninsula, and that's the slipper orchid. I'm going to go into this in lots of detail. So the lady slipper orchid is kind of another trick. It basically traps insects inside, forces them to go out a certain door so it can ensure it gets pollen on the back of the insect. So let's talk about that. So you see, this is a lady slipper cross section. Let me use this pointy thing. So you can see if you were an insect and you crawled inside the little hole that looks like where you put your foot if you were a fairy, now you're stuck in there because this is actually waxy and it's actually curled. So I don't know if you can see, it's got a little twist to it and it's got a waxy surface. So the insects can't really like crawl out there and grip anymore. They're kind of stuck in here. But there's these little lines kind of showing them to the back, and there's these little hairs that kind of produce a little ladder. So they start heading back here to the back. The other thing that's really cool about lady slippers, even the tissue at the back is a little more transparent. So there's basically windows that show the insect where to go. So you can see the light coming through, they can go to the back. And what happens is the insect has to squeeze through a little hole back here. And as it does this, it'll cross this surface. This is kind of opened up a little bit more than normal. Normally this surface would be down in here. But you see how there's little like grippy Velcro on that surface? This is the stigmatic surface of the orchid. So this is the female part that receives pollen. So if the bee has been in another one, it'll smear pollen all over that sticky Velcro surface. Then it has to crawl up this tight back. And this piece here is a big mass of greasy pollen that'll get smeared onto the back of the bee as it exits. So just to summarize, and often the bees that pollinate the lady slippers are little sweat bees. They're very shiny metallic green bees. So they crawl in, they have to go out the back, and they'll get pollen smeared right on their thorax. And then if they come into a flower again, they'll smear it onto this shoe-like structure where the pollen can get transferred. So a super elaborate way to like force an insect to get pollen on it is the slipper orchids. The moccasin flower is also a slipper orchid, but instead of having like a hole for a shoe, it has this little slit here. You can see how a bee would go in that slit, and then it kind of is like almost like a valve. It's hard to get back out. And then also the ramset orchid is the same, but it relies on much tinier bees because it's a very tiny flower. So we have about 6 to 7 slipper orchids in our area, depending on some of them are extirpated and a couple of them are subspecies. But it's really cool that we have this diversity of these slipper orchids that have this really tricky pollination method. Then there's another orchid. This is a prairie fringed orchid. So this is a local orchid that's actually federally endangered. So this is a species at risk. Now you'll notice this orchid's got a pretty basic flower. This is kind of where the insect would come in and get pollen, and it's kind of a little landing pad, nothing too complicated. Except there's this really long nectar spur. So you see these little long things coming out. The nectar is actually way at the bottom of that spur. And then, so something with a really long tongue is the thing that would pollinate it, and that's the hawk moths. So these orchids are white, so obviously they're pollinated more in kind of a crepuscular, like a nighttime or dawn and dusk type period. And so this little orchid face is designed perfectly for a little moth face to fit in there, and for the tongue to reach to the bottom, get a little bit of nectar. You can see that nectar spur there. And so these kinds of orchid moth situations are what they call arms race evolution. So the orchid will evolve a longer nectar spur, and then the moth will evolve a longer proboscis or tongue, and then it keeps going. There's one in Madagascar that I think it was like an orchid specimen that was shown to Darwin or something way back in his lifetime. It was from Madagascar, and it had a 30 centimeter long nectar spur. And so Darwin said, there's got to be a moth with a 30 centimeter long tongue out there somewhere. And sure enough, I think in like the 1920s or something, they found the moth, and it has this really long nectar spur. So they keep just evolving longer and longer spurs. But we have our own example of it here on the peninsula. Another cool one is the grass pink orchid. So you remember I talked about orchids resupinate, they untwist. This one does not, because it actually needs the fancy petal to be on the top. So it actually has its petals are here, and then these are the sepals. So the fancy petal's on the top, so this one doesn't twist. But instead, a bee will land on this kind of little area that looks like it has lots of good nectar, but the actual pollen-bearing structure and stigmatic surface are down here. And so as the bee's weight lands on it, it actually bends down, it's on a hinge, and the bee's bum will hit that little surface, and then it bounces back up, which is kind of cool. And I wanted to mention too that some of our orchids, in fact many of our plants on the peninsula, will have no pigmentation whatsoever. It seems to be really common in our plants in particular, and this was a grass pink that had no, beautiful white one that had no coloration. I've never really heard of it anywhere else, so it might be like a bit of genetic bottling, so we get like kind of DNA that's a little bit inbred and kind of unique mutations happening and sticking around. Another interesting one that is kind of, I would say, a little bit uncertain is the calypso. So in the west, calypsos have this, it looks like kind of a perfect landing pad, and it's the exact same size as some species of bumblebee. And even the orchid even kind of mimics female bumblebees in appearance, and so it's thought that the bee kind of lands on it for sort of deceptive reasons. But here in where they grow on the peninsula, there's really no bumblebees in that habitat, so it's more of just like a landing pad with this little kind of nectar, like this really beautiful little yellow puff of nectar. But it really doesn't have a lot of nectar, so it's kind of deceptive. A bee lands on it and thinks, oh, this is great. It's early in the spring, there's nectar. There isn't. There's just kind of a lie and a trick, and then the thing about these orchids is they bloom really early in the spring, so they actually rely on naive bees, they call them. So bees that don't know a lot and haven't learned enough because they've just emerged. And here's another bit of deviance for you. Orchids often have a very bulbous, particularly terrestrial orchids, a very bulbous root. In Greek, orchis means testicle, that's why they're called orchids. So that's kind of where that comes from. And then this is one of our tway blades. So you can see even your basic kind of orchid that has more of a landing pad for an insect will get kind of elaborate and unique structures to either attract the insect, be visible on the forest floor. This little orchid is like probably that tall. They can be really, really small. So its flowers are about, I don't know, they wouldn't even be the size of a pea really. Super, super tiny. And you can see the ovary. This is the ovary of the flower. Just absolutely swelling, filled with thousands and thousands of seeds in each one. So then we get into the drug phase of the presentation. So we have a non-native orchid called helleborine, and it actually, it's kind of weedy. I'm sure every single person here has it in their property somewhere. But it's kind of an interesting orchid in that it produces kind of narcotic substance that bees, or wasps in particular that pollinate it, get a little bamboozled on, and it kind of keeps them around the patch, and kind of keeps them sort of sticking around and not going too far. So they actually are, there's lots of research still to do on it, but some people suspect as a non-native plant, they're kind of extra damaging in the fact that they're kind of drunkening up pollinators and distracting them from doing their real pollination work. So it's kind of an interesting story. So then we got the thieves and mooches side of the orchid world. Well, orchids were already mooches when we talked about the fungus, but now we've got the full-blown thieves. And those are the saprophytes, or saprophytic orchids. So this is a striped coral root and early coral root. And then I have, in the next slide, spotted coral root. You can see just how tiny these little orchids can be. So the coral roots, you'll notice this striped coral root has absolutely no green in it whatsoever, no leaves whatsoever. It's completely relying on fungus for all of its sugars. There is no chlorophyll in that plant at all. The early coral root, as you can see, has a little bit of chlorophyll in the stem, but still has no true operating leaves. And then the spotted coral root's the same. There's no lick of green in there. It's completely stealing all of its energy from fungus and not producing anything of its own. So these are called coral roots because their roots actually look like coral you find in the sea because they're structured that way to help facilitate all these fungal connections. Orchids in the ecosystem. So orchids are also incredible habitat. Like I almost always find an insect on orchids of some kind. This was a jagged ambush bug. You can see it's got a cute little eye there. And it was sitting in a lady's tress orchid in St. Jean Point, basically waiting in ambush for other things to come around, like pollinators. And then similarly in the showies, I've often seen these crab spiders, and they'll stay white and pink instead of getting kind of yellowy, and they'll just wait in ambush in these slipper orchids to have the next meal. And then even you'll notice here a bit of cobweb there. Like every orchid I see has insects and spiders start to inhabit it, so they do also, I guess, provide depth and diversity in the ecosystem that way. I also wanted to mention, a lot of our orchids that are really nice, you'll actually more so see their leaves than their blooms. And one of those is the rattlesnake plantain. So you've probably seen this little orchid on trails. This is Menzies rattlesnake plantain. So this is super common orchid that we see all over the place. It sends up a little stalk very sort of every few years. Sometimes I think as little as every 10 years. So you don't always see the actual flower. But it'll have a tiny little spikelet of white flowers. But it's actually the leaves themselves that are really cool. It's what you call a basal rosette. So a bunch of leaves in a little row. And here's another, I think this is dwarf rattlesnake plantain, so this is a little more rare. And there's a bit of gold thread here. Actually, this is another rare thing. This is a plant that produces gold dye that you can hardly see up here anymore. And here's how tiny that little dwarf rattlesnake plantain is. So they don't get really, really big. But they're such a joy to find. You can find orchids all year, whether they're in bloom or not, because they have this really beautiful foliage. So the plight of the orchids. So this is a dinner plate or round-leaved orchid that used to grow on a trail on Flowerpot Island that I used to photograph every single year. I would walk out there and visit that little orchid, and it was always there. And then I went one day and there was a hole in the ground where it used to be. And that's happened a few times in my career where there's been a specific orchid someone had a relationship with, would often go see, check on, photograph, and then we would find a hole in the ground. So it's amazing how frequent poaching of orchids and even other things like some of our ancient cedars have been poached and that kind of thing in my lifetime. So it's still a really big threat to orchids. So I try to be really careful about certain orchid species that are a little more rare. I generally try not to talk about like where they are that much, and you'll have all kinds of photographers come up and want to know where everything is, and you just kind of have to be cryptic and say, oh, I don't know, I think we're on Flowerpot Island. Just because it is a real threat, and you never really know what people's angle is. So habitat loss is a really big threat for orchids. About 95% of Ontario's wetlands in southwestern Ontario are gone now. So orchids are often wetland plants, so you can imagine the impact that has. Fragmentation of habitat is also very damaging. Poaching, as I mentioned, loss of pollinators, invasives, genetic isolation. Some of our orchids, particularly the prairie fringed I showed you, because it's such an isolated population, it's actually kind of at risk of a bit of genetic inbreeding. But the really big one is climate change, and I've seen that even in the past 10 years, orchids in decline, or orchids not blooming, or patches of orchids not doing as well, just because they're hotter, drier summers, not as much moisture, kind of a totally different regime when it comes to an ecosystem. Another interesting one is like fire and kind of, I guess, any kind of disturbance. So a lot of orchids have evolved to live in places that have regular fire cycles, and we have obviously been suppressing fire cycles since our kind of major wildfires we had. Having controlled fires is very difficult in a place like this, because it's basically a tinderbox. But even things like, often you'll see orchids on the side of trails, because they do like a bit of disturbance. They'll grow in those areas where there's a bit of light exposure and that kind of thing. So it's something to think about when we think about orchid management is they don't like to be completely left alone, so it's kind of an interesting predicament. So there's a lot of work that needs to be done on orchids. Half the species I talked about today, I wouldn't even be able to tell you what pollinates it because nobody really studies it. It hasn't been done yet, all that kind of work. So just knowing where orchids are and finding a little bit more about them is really important. A really good stat I like to focus on is that a good way to conserve orchids is protecting what we have in situ at minimum 75%. So if you imagine what we have now, that absolutely cannot be touched or sort of altered up to sort of a 75% window. Luckily, a lot of those places on the peninsula are already protected because, almost, 40% of the peninsula is under some form of protection. So that's really good in our case, but when we want that connectivity with other orchid populations and to keep the genetics going, we have to protect more of Ontario. The other big thing that's a possibility is protecting orchids in the sense of like seed banking or cloning them and planting them out, or knowing a little bit more about the mycorrhizal fungi that they use and studying that. So there's lots of groups kind of working away at that, and supporting that research is really important. So ways to help can kind of include a few of the things I mentioned. I don't know if anyone's ever heard of NHIC, but it's the Natural Heritage Information Center. They're kind of the place that likes to keep some of our rare plant and animal sightings in Ontario. So if you're ever interested in doing some citizen science, that's a great thing. There's also iNaturalist, which is an app you can get on your phone. It's a little confounding at first, but it's great. I use it absolutely every day of my life. I put stuff on there all the time. If you think it's something rare that you don't really want to share the location of, you can actually still put the location in and then obscure it or create a private location so no one can see it unless a researcher messages you and asks specifically about it. So that's really great because people like Sam Brinkner, who's kind of running NHIC and doing all that data collection, he's on INET every day. And so if you saw like a cool new population of eastern prairie fringed orchid, he would now know that was the case, and it would be like immediately sort of sent up the ladder of science. So it's really good to participate in those citizen science things. Protecting any existing populations, of course. A big thing with orchids is just not getting too close to them. So because they have that dependence on mycorrhizal fungi, even just stepping near them can kind of tear those fungal threads and kind of rip and tear them. So staying kind of away from the orchids. I always recommend, if people have a pair of binoculars, if you really want to look at an orchid up close, just use your binoculars. You don't have to be super far away, and you can get a really good view. And then a cool tip is if you use your binoculars backwards, they can act like a hand lens. So if you really want to go out looking for them, think about bringing binoculars, and then you don't have to get too close. Teaching others and supporting orchid research and local interest groups and all that kind of stuff. The other really big one is planning and public reviews. So things like CSIWEC, which is the big group that deals with species at risk, when they have a plan go through, it goes through like public approval and review, so it's really worth plugging into that. But even locally, when we have like official county plans or any kind of municipal planning, it's always good to keep an eye on some of those in the context of these kind of conservation, and easements and all that kind of stuff can play a really big role in protecting species, and it's often a hard sell, so we have to make sure somebody's standing up for it. One really great resource if you're interested is the North American Orchid Conservation Center. So the U.S. Botanical Gardens and the Smithsonian have kind of created this center, but they have a super cool website, section of their website called the Orchid Donnie section, where you can actually print out several of our orchid species and make little models out of paper. So if you and there's actually quite a few of our local species. So if you have any grandkids or anything, this is a great way to get them into crafting with orchids and experiencing orchid biology in a out of bloom time, which is kind of exciting. So this was a shot from, I think, the Petrel Point Fen, and this is really amazing. You've got a ton of really interesting sedges. There's some tuberous Indian plantain that's not in bloom. This is grass pink orchid, rose begonia orchid, lady's tress orchid. There's some linear leaf sundew in here, and a carnivorous pitcher plant, all within like less than 1 square foot. I don't know many places left on planet Earth that have this kind of like incredible plant diversity. I mean, I'm a big rock person, as everyone knows, and the peninsula is very famous for its rocks. People want to look at grotto and flower pot and the cliffs. But I have to say the botanical diversity of the peninsula, to me, is probably its real special point. It's world class when it comes to botany. Like, people come all over the world to visit the peninsula because of how rich it is. So there's not many places you would find a literal garden that was planted by nature that has 3 orchids and 2 carnivorous plants in a little section like that. It's absolutely amazing. And I often think to myself about, was born and raised in the Eastern Township area, but I was raised in Swan Lake area, which was drained a long time ago for agricultural use. But when you read really old botanical surveys from the 1930s and 40s, they talk about all these orchids by Lion's Head that were probably in some of the areas of the big eastern swamps. So Swan Lake was named because it was surrounded by ferns that looked like the heads of swans. And there were so many orchids in this one fellow's list that were near Lion's Head. I was like, I bet you they're near in all these kind of fern environments. So sometimes I think about what orchids must have been like then compared to what they are now. And I always try to think of working towards that preservation of a species that's really been in this diverse habitat for so long. And that's that. And I brought a bunch of orchid books. I stole an orchid from my mom's house because I wanted to show you that neat little flesh they have on the roots. And then I have I brought some of my scientific illustrations and a few little orchid paraphernalia. I love that the provincial flower for PEI is the moccasin flower, but often you'll see on like Old China, you'll see our showy lady silver orchid and all that kind of stuff. So I have a few little bits of orchid paraphernalia for everyone to look through. And yeah, thanks so much.
Okay. Any questions?
Yep.
I'm just wondering, with respect to restoration of old agricultural lands.
Yep.
Are there any particular trees that you think should be planted in order to encourage some of those, what we call it, dormant, I don't remember the word used, dormant orchids that might be still underground but just not blooming? Like you mentioned the moccasin and pines.
Yeah.
I didn't know if there was anything else specifically that.
Yeah, I think the best thing, I guess, with restoration is thinking about recreating diversity as much as you can. So I don't know if there's any one particular tree, but if you're restoring an area, trying to sort of create the whole system. So say you're planting some maples because you've got some really deep soil there. You're going to plant a couple maples and oaks and that kind of thing. That's probably going to become a deciduous forest, which not a lot of orchids grow in anyways. But if you've got kind of more of a cedary environment, to be honest, just keeping it kind of as rich and as invasive free and as diverse as you can do it is the best. Because a lot of agricultural areas will have either altered or denuded fungal diversity. So it's not so much the plants that are there, but the fungi in the soil. So because of say herbicide application or constant tilling or different things like that, or even compaction from cattle, depending on what the land is used for, you might have like a different fungal diversity there than what would have been in the past. So it's kind of about creating as much diversity as you can to bring that fungal diversity back up.
It's hard to know, even on the peninsula, what the original diversity looked like.
Yeah.
Because of the forest fires and also the
Agricultural,
logging.
logging. Well, a lot of, if you're in the Eastern Flats anywhere, it was wetland, that's for sure. If you're anywhere else where you got kind of that like dry upland, kind of what we call marginal agriculture, like there's rocks poking out and stuff, odds are that was some kind of forest. And that's kind of your two bets you can make. So most of the agricultural land in Lindsay, I would say, was probably forest or floodplain because of the Stokes Bay River. And then most of it here was wetland and forested wetland. So like northern Eastern Flats where I live, there's lots of black ash and green ash, and kind of it was an ash dominant swamp. And then when you get sort of south to the clay plains of the southern Eastern Flats, it's more like a cedar swamp. So those are some things to keep in mind if you have any swampy land, those are the species that do well. But again, it's kind of the fungal diversity that's the key. So, and that's just going to happen naturally as a system kind of is able to regenerate itself. It's worth mentioning a couple invasive plants, like I think, well, the juglans, like if you had a horse chestnut or something in your yard, but say the garlic mustard, they can be allelopathic, so they can put out toxins that kind of harm other plants, but those toxins can also harm the fungi diversity in the soil. So invasive plant management is another really, really big one.
Yeah, because we're doing a lot of garlic mustard removal and
Yeah.
very recall the other one. And
Yes.
Lily the Valley, actually.
Okay,
Those
yeah.
three are
Yeah, pretty voracious.
pretty bad.
Yeah.
Are there more yellow lady slippers than there used to be, like 10, 15 years ago?
Yeah, it seems like it sometimes, eh?
Yeah.
Because they're so numerous. I don't know what the answer to that would be. They love disturbance. They love the ditch areas where there's lots of light and like no other. Again, they don't have to compete with as many other plants. So it could be that because we're getting kind of hotter, drier summers and milder winters, that we might have like a temporary boon of that species. I don't know if it would be for a long term though, because a lot of we've noticed a couple. I don't know if you've noticed how the trees had a bit of a different blooming and fruiting pattern this year, and like some of the spruces have like longer growth on them. So I think like the mild spring they liked it, but over time that's probably not going to work out well because they're going to kind of overdo it and that kind of thing. But yeah, I don't know. It's possible.
Well, it's just that, where we are, so we've been there for 35 years, south of Barrel Bay, and we didn't have lady slippers in the ditches there.
Okay.
And now we do. They've been around for about the last, 6 to 10 years. They've been showing up to the side of the road.
It's good. Yeah. Yeah, the yellows are one thing we don't have to worry about quite as much because they also like a variety of fungi too. So they love those disturbed roadsides and they love quite an assortment of fungi, whereas some of the other ones are a little more specific. That's another thing, speaking of ditches and lady slippers. There's been a couple of our ditches that had showies that the municipality has then cut or re-dug the ditch out.
Yeah.
And so one other thing I always try to mention to the municipality when I'm with them is, if you're ever doing a ditching project, let someone know, let like the NCC know, or let like a local group know, like BPEG, and they could work on like relocation or something along those lines, sending those plants to a research institute like the Gosling Research Institute in Guelph does like clonal propagation, so they can actually clone plants out. They're working a bit on orchids because they're more tricky, but you know, so that we could do more with those plants other than just dig a ditch and call it a day, and then we lose them. So that's another thing you can do is keep your eyes peeled for that. And remind the municipality to let us know before they do that stuff so that we can help make it go easier, I guess.
And the one that you mentioned that probably everybody has at their,
The helleberry, yeah.
yeah, I mean, every year I have more and more of those. So
Yeah, me too.
it sounds like when you say they interfere with real pollinators, it sounds like they're not a good thing necessarily.
Yeah, the research is still kind of early on that, so I mean, I'm not running around picking them out of the ground or anything. But like
I
some,
do.
yeah, and if you want to, that's fine. But
I don't take them all, but I do.
yeah. They're kind of a hard. They've naturalized in a way that they're never going to be garlic mustard. They're not going to be like a wall of helleberine. So it's not kind of the same worry that some plants are.
Yeah.
And because those broadcast seeds can be like up in the aerial plankton, it's going to be hard for us to kind of keep on top of it. But yeah, if you want to regionally.
I like them. They're amazing.
Yeah.
I love looking at them.
Oh, they're quite beautiful as an orchid, yeah. And they actually look very, very similar to lady slippers and ram's heads. So I've always cautioned people about worrying about picking them because I'm worried they'll get the wrong orchid when it's not in bloom. Like it's pretty obvious botanically, but some people think it's a lady slipper, and I mean, well, just don't worry about it then, because they're never going to grow, you know, in droves or anything. But yeah, they do have that interesting impact.
The folks that come up and dig out, especially the ladies, the showy lady slippers.
Yeah.
I've had a lot of those disappear along my
Okay.
road. It's my understanding that they don't transplant well.
No.
Would it be because of the fungi?
Yeah.
Because of that. So these people that dig them out, they take them and then they just die.
Presumably, yeah. Like I don't know not much about the black market of orchids, but I can't see how they could they've never propagated them. So how could you possibly keep it alive for very long?
Yeah.
But I think there's a black market like that. Like some of our, there's even turtle species in Ontario that you could get, I don't know, $260,000 for one on certain black markets. So
Wow.
I don't think it's people who know a lot about stuff all the time. It's people who hear about it as a thing, are desperate and do it kind of thing. So
Jenna,
yeah.
What is the relationship with mosses and fungi? Is there a relationship, or because I often see a lot of moss in relationship to some of the lady slippers, for example?
Yeah. Well, I wouldn't know specifically about that. One thing that is obvious is that when moss is healthy and diverse, the whole ecosystem is. Like, it's a good indicator that things are good because it depends on, you know, a bit of a humidity and a moisture regime. So that's kind of like when you see a good thing, you're going to see other good things. I don't know anything about like a specific relationship though. I mean, there's possible that there's more to it, but I don't know of anything. Like moss aren't mycorrhizal or anything. Like they don't have true roots, so they wouldn't be really connecting to that fungal network necessarily. Yeah, there could be species of fungus that live off of moss, and meaning like some species of fungus live off living things as opposed to dead things, but I don't really know.
Okay, and the second question is, tamarack seems to be associated with orchids.
Yeah, probably because you see them in those wet fens, and tamarac's one of the only things that can stand that like wet flow, constantly having its feet wet kind of trees. So are cedar, so are black spruce. So that's maybe why it's the habitat kind of thing. I'm trying to think if there'd be anything else about that. Even in drier areas, I don't know of any orchids that grow in kind of dry tamarack zones. The other thing is tamaracks often really like dune and soil complexes, and there's quite a few orchids that you'd find in there as well. So that could be another reason.
I don't know if you've heard of Phoenix perennials.
Yeah, I have heard of them.
They're selling orchids, all these hybridized
Okay.
versions for like they're like $100 each. I just sort of wondered what you thought. I don't know where what they're doing, cloning.
Yeah, they're like kind of like native ones, but hybrids. Is that what you
Yeah,
mean? Yeah.
they come in like the showy lady slipper comes in all white or yellow and white or reverse of pink and the white. Like it's incredible how much diversity there is. But I wasn't sure like whether they would also. I would think they would be specific, just like our native ones would be, and maybe be highly risky to purchase. Not.
Yeah, I don't know what the ethics of where they source their material would be. Like that would be one consideration. Like, are you using very old nursery plants to do this, or are you going into the wild still, and what does that mean, kind of thing. But the slipper orchids, particularly showies and yellows, actually are often sold in nurseries because they are a little more generalist about the fungi they like. And then, again, they don't mind disturbance. You'll see them on roadside ditches and that kind of thing. The showies do like wet areas, but they're not quite as particular as some other ones. So I've seen like Earthbound Gardens often even has yellow lady slippers for sale. But I'm not really sure like what the front end of that looks like how those are sourced or grown, or what the genetics of them might be, because that's another thought is like about when you're doing any restoration ecology is often wild ginger. You get a wild ginger at like a plant nursery over in Omimi, and it's obviously kind of speciating away from our wild ginger because it's the flower will be very different and the leaves will be very different. So yes, it's the same species, but they're obviously quite different genetically, and possibly you're introducing completely new genetics, which could be good in the case of inbreeding, I guess, but also could be negative in the case of like the genetic integrity of your area. If a plant has a specific like medicinal use in an area, that may be tied to its unique geographical genetics rather than it being a species in general. So I don't know what the ethics on that would be, but
it's the whole native art kind of discussion, right?
Yeah.
Which doesn't seem to be getting resolved very.
Yeah, but I mean, the other thing to be argued is if there's a nursery that's being able to propagate orchids on their own without any touching wild anything, so they're feeding that need that people have, then maybe that's a good thing. I don't know, instead of it being from wild populations. I don't really know what to say about the hybrid lady slippers.
They're very beautiful.
Yeah, they're stunning. Yeah, they would be hardier too if people are interested in growing them, because orchids that are even like very sensitive in the wild, sometimes when they're propagated, they're very, very hardy. I think it's because if they survive that long, it's a hardy stock, but also they've got all kinds of extra additions and that kind of thing that are kind of different than the wild conditions. So sometimes they can be hardier than you'd think, in the case of that one, for example. Yeah. Yeah.
I got the sense that orchids don't really have much in the way of scent. Do they?
Oh, yeah, some of them do. In fact, some of those ones that are deceptive will have a scent, just no food. So they'll smell like nectar, smell like a little bit of some of them even have a bit of a vanilla smell, because a few of our orchids are from the same super order of the vanilla orchid. I can't remember which taxonomic classification it is. So some of them do have a bit of a scent, but they just may not have a reward. They're kind of deceptive in that way. They're very lazy. They want to lure people in with their beautiful ideas, but don't really have anything to provide. So it's like Facebook, basically.
All right. Thank you, everybody. Thank you so much, Jenna.
Yay.
We'll see everybody next month, July 3rd, Wednesday, July 3rd. I just want to make a comment that we are videotaping these for YouTube, so there are some people at home watching this live. In order for us to do that, we need a minimum amount of subscribers to our channel. So if you are on YouTube, if you can go to Bruce Peninsula Environment Group and just hit